We're going to discuss graphing. There are many types of graphs: bar graphs, line graphs, circle graphs, which are pie graphs, but the one I'm going to discuss is line graphs. I have very different expectations from your math on what should be on a graph and what your graph should look like. One thing is a title. Title of graph will always be whatever is on the y-axis versus the x-axis. Okay? The second thing is your axes are labeled. The third is units for the title and units on the axis. The fourth thing is that the separation is consistent. So consistency on numbering the axis. And then the fifth thing is a best fit line. So let's look at some numbers. We are going to graph distance and mass. And the distances are 16 centimeters, 40 grams, 14 centimeters, let's do 30 grams, 12 centimeters, 20 grams, 10 centimeters, 10 grams. Okay, so these are my numbers. Now, as I changed the distance in my spaghetti lab, the mass changed. So my distance will be my x-axis, and my mass will be my y-axis. So, let's divide up our scale. The scale between the numbers have to be the same. We know distance is going up to 16. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 spots. When you are doing graphs on graph paper or in your lab book, you want to use at least half the page. I've got this set up to where I'm using half the page. Let's see, we're going from 6 up to 16 centimeters. So I'm going to start at 10. 12, 14, 16. Okay, and now we are going up to 40 grams. Now, so let's say this is 20. This will be our 10. If you notice, my scale on my X side, this scale, does not have to match, our Y scale does not have to match our X scale. They can be set up different looking. That is fine. But notice the spacing from here to here and from here to here is the same. That's what you want. So we had 16 and 40. We had 14 and 30, 12, 20, and 10, 10. When you place your dots, you want to put a little circle around them. It's kind of hard doing this with the iPad. Okay. Best fit line is a line that divides your data equally. The equal number on top to bottom. So, to do the best fit line will be something like that. It does not have to go through the data points. It can. It doesn't have to. You want to get as close as possible. So this is a graph. The next thing you do on a graph, if it is a straight line, you have to find out about that graph. So, since it is a linear graph, you can find the slope. And slope of a graph, if you remember from your math, is rise over run. So, you want to pick points off your line. So, I am going to pick, this looks like an easy point. And this looks pretty easy. Okay, so here, and I didn't quite get it, but it's really at 40 and 16. It goes back to the graph being funky looking. So we have these points. Now, this point is our X is 16, our Y is 40, and this point is 13, or see 11, and 13. So rise, how high it went, so that's the change in Y over the change in X, which is Y2 minus Y1 over X2 minus X1. Put in what we know. We know our numbers. So that means this is 40 minus 13 over 16 minus 11, which is 27 over 5, which is 5.4. Okay, so we have a slope of 5.4, but 5.4 what? So we have a slope we calculated to be 5.4. But we're wondering 5.4 what? Well, it's what you divided. So we had 5.4. Our rise was mass, which is grams, divided by our run, which was centimeters. So the slope of our line is 5.4 grams per centimeter. So what does that mean? That means for every centimeter moved, mass increased by 5.4 grams. That is what slope means. And that's what you will be finding on these graphs. When you do a graph and you get a straight line, you have to find the slope.